Hey there, this is Mathcamp321 presenting another lesson on limits, this one specifically on one-sided limits. One-sided limits in 5 examples. And my biggest strategy that I can give to you for dealing with questions of this type is to have a sketch available if possible. So if you'll notice 1a, 1b, 1c, they all deal with the same function. So before I even start and look at that question, I want to actually get a quick sketch of what that is. So if I think of the square root of 4 minus x squared as its own function, some of you might know exactly what this looks like, but others might have absolutely no idea. So a couple things to think about when you're trying to sketch something. You might want to consider the domain. Now the domain for this function, because that expression 4 minus x squared it lives underneath a radical, we know that it has to be non-negative. So we can say that 4 minus x squared must be greater than or equal to 0. If we factor that expression on the left as a difference of two squares, we get 2 plus x and 2 minus x. Setting each of these factors equal to 0, we get two boundaries for our number line. The first boundary is x equals negative 2, and the second boundary is x equals positive 2. So I've gone ahead and I've put those values onto a number line. Now, because of the inclusion of the equal sign here, I know that these boundaries are going to be included, so I'm going to use a closed circle. And there are 3 regions. There's region 1 off to the left, there's region 2 in the middle, and there's region 3, which is off to the right. And what you're going to do is you're going to pick test values from each of these regions to see where the inequality is true. And you're going to go back and plug those into either this one here or this one here. You can manually plug the numbers in, or you can just look at it. If I take, for example, negative 5, which would be something over here, let's say I'm going to test negative 5. Negative 5 squared is 25. 4 minus 25 is something negative, and that's not greater than or equal to 0. So this does not work. In the middle region, an easy, convenient test value might be 0. 0 squared is 0, and 4 minus 0 is 0, and that does work. And then if I test something over here, let's say positive 5, it's going to be the same exact outcome as over here, so that's not going to work either. So the domain is going to be everything between negative 2 and 2 inclusive. Another thing that I could check is the y-intercept. To find the y-intercept of any function, I let x equal 0, and then just plug in. So if I let x equal 0, the only thing I'm left with is the principal square root of 4, which is 2. So as it turns out, this is actually going to be a semicircle. And another reason I could have known that is to think back to your general HK form of a circle. It looks like this. Now let's say in this case that the r squared is equal to 4. If I isolate y squared, I get y squared equals 4 minus x squared. And then if I take the square root of this, technically I should have plus or minus the square root of that expression on the right. But if I drop the minus, if I get rid of that minus, it's only going to be half of the circle, namely the top half. So what I'm going to do now is I'm going to actually get rid of all of this now that I know it is a semicircle with radius of 2. So I'm going to get rid of all of this stuff here so I have room to sketch the graph. Okay, so we said it was a semicircle. The domain started at negative 2 inclusive, it ended at positive 2, and it had a y-intercept of 2. And we said it was a semicircle, so we could just go ahead and freehand this. Okay, not terrible, but not amazing either. Okay, so now we're ready to look at these limit questions. So the first question says, find the limit of this function as we approach, or as x approaches 2. So let's find x equals 2. It's right here. And to answer a limit question, we start by leaping a little bit to the left and then approaching. And as we approach toward that 2, the y values are dropping towards a value of 0. The problem is you're also supposed to jump to the right, and it's supposed to go to the same thing. And if I jump to the right, the graph doesn't even exist. It's not part of the domain. So this limit question cannot be answered. I'm going to write DNE does not exist. And the reason for that is that the graph only lives on the one side. Now, if I refine the notation, I'm able to answer the question. So if I look at 1b, it says, find the limit of this function as x approaches 2 with this little negative superscript. It's like the power of negative. What this means is approaches from the left. This little negative means approaches from the left. So now if I go to that 2 and I approach only from the left, the y values are dropping and dropping and dropping and dropping, and once I finally get there, they're getting to 0. So the answer to this one is 0. My third example is the same exact thing, except now instead of a minus, there's a plus. X approaches 2 with a plus after it, and this means approaches from the right. So if I find x equals 2 and I approach from the right, there's no curve to the right. So this is also not possible. So I'm going to write DNE. So these three questions, the only one that I was able to do was 1b. So in just this one example, we learned a couple things about new notation. If there's a little superscript negative, that means approach from the left, and if there's a superscript plus, it means approach from the right. Okay, in our second example, we've got a very similar function to the example in question number 1, except the thing under the radical, the radicand, is written in reverse. So if you remember on the other screen, it was 4 minus x squared, but now it is x squared minus 9. So it's not going to be a semicircle. It's what I call the IDK function. An IDK, if you're a heavy texter, IDK, this is I don't know. And there's an international symbol for I don't know. They shrug their shoulders and they put their hands up. Just imagine what it looks like. So I've nicknamed this the IDK function. This is nothing official. If you go to college and you talk to your professor about the IDK function, he or she is not going to know what you're talking about, but I think it'll make sense once I draw it. So if I consider the domain, the two key points are going to be 3 and negative 3. And this time, instead of the graph going in between negative 3 and 3 and making this semicircle, it's actually going to go out from those 2 points. So it's going to go like this and like this. It kind of looks like the shrugging of the shoulders and the two hands coming out saying, I don't know what the answer is. And the whole thing is also shifted up 1. So there's a lot of interesting things happening here, but based on your familiarity with pre-calculus, that will really help you come up with these graphs more quickly or not. So hopefully you've got a solid foundation in that. So let's go to our first question now that we have that graph done. The first question is find the limit of this expression as x approaches 3. So let's find x equals 3. And the first thing we typically do with the limit question is we jump a little bit to the left. But already that's an issue because there's no graph immediately to the left. So this limit question cannot be answered. I'm going to write DNE. If I go to number 2, it's find the limit of this expression again as x approaches 3 from the left. So if I find 3 again and I go specifically just to the left, I still can't answer that question because there's no graph immediately to the left. 2c, maybe this one will bring us better luck. Find the limit of that same expression as x approaches 3 from the right. So I've identified at x equals 3, I jump a little bit to the right, and yes, the curve lives there. And as I approach 3, the y values drop and drop and drop, and they drop at, as you may have guessed, 1. So the answer to this question is 1. Having the graph right in front of your face really makes a big difference. A lot of students will try to answer these questions without producing a sketch, and it often doesn't work out well. So if you can quickly produce a sketch or use your calculator, if you're allowed to use the calculator for this question, then I would really suggest going ahead and doing that. Let's take a look at another example.